Have you ever looked up at the night sky and wondered how telescopes bring distant planets, stars, and galaxies so much closer? How does a simple tube of glass and mirrors have the power to reveal the hidden details of the universe? Imagine staring at a tiny speck of light in the sky, and then, through a telescope, seeing that same speck transform into the rings of Saturn or the swirling storms of Jupiter. The secret lies in how telescopes bend and manipulate light, turning distant objects into breathtaking sights. A telescope magnifies objects by collecting far more light than the human eye can, and then bending that light in a way that makes faraway objects appear larger. Think of it like a bucket collecting rain. Just as a larger bucket gathers more water, a larger telescope lens or mirror collects more light, making even faint and distant objects visible. This is why observatory telescopes are so massive. They need to capture as much light as possible to reveal the secrets of deep space. The process begins when light from a distant object, such as a planet or a star, enters the telescope. If the telescope uses lenses, it is called a refracting telescope. The first lens, known as the objective lens, is curved in a way that bends the incoming light rays, so they converge at a point. This creates a smaller, focused version of the image. Then the second lens, called the eyepiece, takes this focused image and magnifies it for our eyes, making the distant object appear much larger than it actually is. Picture a magnifying glass focusing sunlight onto a single point. That's similar to what an objective lens does, but instead of sunlight, it gathers light from far-off stars. Then the eyepiece acts like a second magnifying glass, enlarging that focused image so we can see the details. There's another type of telescope called a reflecting telescope, which uses mirrors instead of lenses. In this design, a large curved mirror at the back of the telescope gathers light and reflects it toward a smaller mirror, which then directs the light to the eyepiece. This design allows telescopes to be much bigger without needing enormous and heavy glass lenses, which would be difficult to support. Some of the most powerful telescopes in the world, like the Hubble Space Telescope, use this design. The amount of magnification a telescope provides depends on the combination of the objective lens or mirror and the eyepiece. If a telescope has a small lens or mirror, magnifying the image too much will only make it blurry and dim, just like zooming in too far on a low-quality photo. A high-quality telescope needs a balance of light-gathering ability and magnification to produce sharp, detailed images. Another key factor in how a telescope magnifies objects is focal length, which is the distance over which light is bent before it reaches the eyepiece. A longer focal length means the image is spread out more before being magnified, allowing for greater detail. While the basic principles of magnification remain the same, modern telescopes have advanced features that allow us to see even further. Some use adaptive optics, which adjust for distortions caused by Earth's atmosphere, making the image sharper. Others, like radio telescopes, collect different types of light that are invisible to our eyes, revealing hidden details about the universe. The ability of a telescope to magnify objects is what has allowed humanity to explore the universe beyond what we can see with the naked eye. From Galileo's first simple telescope that revealed craters on the moon to the James Webb Space Telescope capturing the earliest moments of the universe, these instruments continue to expand our understanding of space. If this is what we can see today, imagine what telescopes of the future will uncover. What incredible discoveries are waiting just beyond our reach.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.